Hello, welcome back to the final part of my series on uncertainties. Today we're looking at graphing uncertainties. So the first graph we're going to look at, this is for the A-level part, is a graph of terminal potential difference. So that's the potential difference at the end of a cell with a load applied against current. So you'll have seen this equation, this graph, in your required practical 6, finding the EMF and the internal resistance of a cell or a power supply. And you'll have drawn a graph which looks like this, and you'll have found the gradient to find minus R, the internal resistance, and you'll have found the y-intercept in order to find epsilon, which is the EMF. So the question is, after we've found the gradient, which is a great way to reduce random uncertainties in a result, how do we find the uncertainty in our gradient? So for A-level, the first thing you do after you've drawn your line of best fit is draw your worst line of best fit. So you've been trained for years to draw the best line of best fit you can with even numbers of points on the top and bottom of the line. And now what I'm saying is you draw the worst line of best fit that you can. Okay? So when you've got your worst line of best fit, either the steepest one that you can find or the shallowest one you can find, here that's the red one and the green one, the red one's the steepest and the green one's the shallowest, then the worst possible gradient is the one that you're looking for. So these are lines of best fit that you could draw, but they're not very good. Okay, so don't be too pessimistic and don't be too close. It's a bit of an art. In the IB it's slightly more logical. There's a way to figure it out. But with the A-level, if you're asked to find the uncertainty in a gradient, you draw your worst line of best fit. Okay? In order to find the percentage uncertainty in the gradient, you take your worst gradient minus your best gradient all over, so that's your absolute uncertainty on the top, or an estimate of, and then you can multiply that by 100%, get your percentage uncertainty in your gradient. So you take your worst gradient minus your best gradient to find some sort of estimate of the absolute uncertainty, divide it by the best gradient times by 100 to get the percentage uncertainty in your gradient. In order to do the same thing for the y-intercept, it's very similar. So you look at your worst y-intercept, so which one's furthest away from your best. And you take your worst y-intercept, you take away your best y-intercept, you divide by your best y-intercept, and then multiply by 100%. Okay, so in each case it's the worst minus the best, all divided by the best, multiplied by 100%, give you your percentage uncertainty in your gradient, whatever value that might be. And always be careful that when you're working with gradients, you're probably going to have a unit. So in this case our unit is ohms for the gradient, and for our y-intercept your unit is the same as the values on your y-axis, so that is units of potential difference, that's volts. So that's graphing uncertainties for the A-level. With the IB, in order to draw our lines of best and worst fit, we have to use uncertainty bars. Now we can use uncertainty bars in A-level, but there's no stipulation that they need to be used when you're doing lines of worst fit. In this case, our steepest line goes from the top, so if we draw a box around here, this is our uncertainty in that quantity, and a box around here gives us our uncertainty in this one, this plot here. So our steepest line of worst fit goes from the top of this box to the bottom corner of this box, and then our shallowest goes from the top of this box to the bottom corner of this box. So this will be examined like this in your exams, in your paper 3. Now, the only time when this isn't the case is if this line does not go through the uncertainty bars on all of your other points, in which case you need to move the line. Either, if you can't make it to this end, move this end, or you can move this end, so that it goes from either the top corner here or the bottom corner here, goes through as many of the points as possible. In fact, it goes through all of the points and ends up somewhere near the top corner of this one. Yep, so it's slightly different. We've got a different graph this time as well. We've got displacement on the y-axis, and we've got t squared on the x-axis. So in this case, we've got on the y-axis s, on our x-axis t squared, and if we're using the equation s equals ut plus a half at squared, a half a, because we're doing free fall for this experiment, so this is finding g by free fall, where g is our gravitational field strength, but it's equal to our acceleration due to gravity. So the gradient of this line would be g over 2, and ut, because we're starting from rest, ut is 0. Okay, so our y-intercept is 0, so we should pass through the origin, and our gradient should be g over 2. So in this case we're not finding percentage uncertainties, we're finding the uncertainty in our gradient. That's going to be your maximum gradient. I'm going to use shorthand for this, minus your minimum gradient, all over 2. So it's quite similar to our finding half the range of the results if we do repeated results. Quite similar to that. We've got the maximum minus the minimum divided by 2 to find an estimate of our range of gradients. To find the uncertainty in the y-intercept, it's very similar. It's your maximum y-intercept minus your minimum I'm going to run out of space, intercept, all over 2. And then you can convert those to a percentage using our method for finding percentage uncertainties from the first video in the series. I hope that's been useful. I hope the whole series has been useful. I'll just scroll up slightly so you can see the two different ways for A level and for IB. If you've got any questions, put them in the comments. Give me a like if you liked it. Let me know what was good, what was bad. I'll see you soon for another video and a live stream.